Good afternoon, Algebra 2. We are going to be covering Lesson 47, Graphing Exponential Functions. Now you have two options. You can use a graphing calculator, which is Desmos on your iPad, or you can build a table using your calculator. So either use Desmos or a calculator. It's up to you which you prefer. So there are two kinds. First of all, an exponential equation is where x is the exponent. For example, y equals 2 to the x. Notice x is the exponent. So an exponential equation doesn't just have an exponent, it has x as the exponent. Okay, so x is actually in the place of the power. There are two kinds: growth, which is a graph that slowly, and then it starts out kind of slow and then it just takes off, but notice it grows as you move from left to right. And a decay does the opposite, starts high and moves low. Okay, so we're going to jump right in to lesson practice on page 340, part A. We are going to graph y equals, and I didn't write y equals. And you know what? I will go over really quick. I forgot to go over a couple things. So in exponential equations, you have like this bottom floor to each one that your graph seems to be getting closer to but never actually touches. And it has a mathematical term. This line or floor that your graph is getting closer to is called an asymptote. Okay, and it is a value for y. And it can be, most time y equals 0, y equals 2, but it is a value that your graph approaches. It doesn't actually touch the line, and it doesn't actually equal the line. It just gets closer and closer to. We will also be doing domain and range for these, okay? So let's go into part A officially. So we're going to graph y equals 1/2 to the x. Now I'm not going to use a calculator. I want to go over why we get certain values, and then I will show you, if you want to enter this in your calculator, what that looks like as well. So here's x, here's y. In the middle, I'm going to show you my work. Okay, so I'm going to do, it's important if you are building a table to include some negative values and some positive values. So I'm going to start with the -3, so I'm plugging this in for x. So 1/2 to the -3 would mean that I would write the reciprocal, 2/1 to the third. And I'll move this up. Now, I don't know if you remember, but negative exponents means we write the reciprocal and make the exponent positive. So this is now just 2 to the third, which equals 8. So if I was to enter this in my calculator, you do parentheses, 1 divided by 2, write 1/2, use the arrow, 1 divided by 2 to the -3rd. Notice it also gives me 8. So showing you both. Next one, 1/2 to the -2nd, right? I write the reciprocal, so that becomes 2/1 squared, which equals 4. If you want to confirm, 1 divided by 2 to the -2nd is 4. Next one, 1/2 to the -1st, write the reciprocal, so 2/1 to the first, which equals 2. You can also use a calculator, so 1/2 to the negative. Notice I put it parentheses around the fraction, and I get 2. Next one, 1/2 to the 0th power. Anything to the 0th power equals 1. So 1 divided by 2 to the 0th power, 1. Next, 1/2 to the first is just 1/2, which is 0.5 Decimals are easier to graph. We can confirm here. 1 divided by 2 to the first power, 0.5. Okay? Next one, 1/2 squared. Well, that would be 1/2 times 1/2, which equals 0.25, right? It equals 1/4. So that is where I'm getting that. So 0.25. This next one, 1/2 to the third, would equal 1/8, which is the reciprocal of that. This 1/4 is the reciprocal of that. 1/2 is the reciprocal of that one. So anyways, this should be 1/8. 1 divided by 8 is 0.125. So you can use your calculator, look 1/2 to the third, and it'll give me that decimal. Okay, so you can use a calculator. If you don't want to use Desmos, or you don't feel like opening up your your iPad, you are more than welcome. So I'm going to, I won't always go to the largest number, but we got 8, 6, 4, 2, 0 should be here. Now, for those of you who are moving on in mathematics, let's go over the asymptote and where it's at. So 1/2, no matter how large or how small that exponent is, my answer will never be 0. So I create this floor or this line where a y equals 0. So that would be my asymptote. So my asymptote is at y equals 0. Okay, that is going to affect my domain and range, and we can do that without even graphing it. My domain, I can plug anything in for x, so my domain is all real numbers. My range, however, is going to be limited to where my asymptote is. So if we were to plot these points, -3, 8, -2, 4, -1, 2, 0, 1, 1/2, 1/4, 0.125. So if you look at the pictures I drew above, this is a exponential decay. And notice my values are above 0, so I would say greater. It cannot equal, it'll never equal 0. No matter what I put, if let's say I do 1/2 to the 100th power. Oh, well, okay, it's rounding. That's a bad example, huh? Notice I just get a smaller and smaller and smaller decimal. I know that says 7.8, but I would have to move the decimal to the left 31 times. So I just get a smaller and smaller number. Next one. I wonder if I can fit this. I probably can. So part B. They'd like us to graph the following. Y equals 3/4 to the x, and y equals 4/3 to the x. Now I'm going to show you how to use Desmos if you're unfamiliar with it, so you'd have to open it up. Now Desmos will do everything for you. It's a really nice program. But if you want it to graph, you simply start with y equals, so I have to turn it so it doesn't show the glare. So y equals, in parentheses, I'm going to enter this first one, 3/4. Close out the parentheses, and then I have to hit this A to the B button. Whoops, not there, obviously. And hold on. I think I have to hit enter. Yep. And then out here to the X, and notice it graphed it for me, and so I could use the graph to build my table. Okay, so that is one way. You can just enter it, you'll see the graph, and then zoom in to find where your points are. I'm going to use a calculator and good old table for each one, and then I'm going to graph them because part B asks us to describe the graphs. Okay? So I'm going to do the one on the left. So I'll do -2, -1, 0, 1, 2. So 3/4, 3 divided by 4 to the -2nd. And I get 1.8. And then if you have a nice calculator, you can just edit the entry, 1.33. If I go to the 0th power, I'm going to get 1. 3/4 to the first power is 3/4, so 7/5. If you don't believe me, you can go up here and change that to a positive 1. Look, I get 0.75. And then let's change that to a 2. So 0.56. Okay, next one I'm entering 4/3. So I'm going to go up here and change this to 4/3, and we'll do -2. And, oh, 0.56, -1, 0, 1, 2. Change this to 1, -1, sorry, point. Oh, interesting. Wonder if you guys see the pattern here. 1. So let's look at our tables. Do you guys notice my y values are almost this, or are the same, but flipped? It's because my fractions are reciprocals of each other, so the y values are reciprocals of each other. So I'm going to graph both, and then we'll talk about how that looks on our graph. And then we will also do domain and range. So I have small graphs. I hope you can see that. We can change the scale if you like. So this is 1, 2, 3, but I'm not going to change the x-axes. All right, so I have the same asymptote here. I'm going to graph this one in blue. So -2, and this would be 1.5, so 1.8, 1.5, so 1.3, 1, 0.75, 0.56. Okay, this next one I'll do in red. -2, if this is 0.5, 0.56, 0.75, 1, 1.3, 1.8. Please do not make straight lines. So my fractions are reciprocals of each other. My y values are reciprocals of each other. And when I graph it, I notice these are, it looks like the graph has been, it's a reflection across the y-axis. Now the domain for both is the same. The domain is all real numbers. And for both, the range is y is greater than 0, which is where our invisible asymptote lies. Part C. Now, I believe Part C says graph the following functions and describe the graphs including domain and range. So I'm going to do all 3 so we can describe what's happening. So y equals 2 to the x, y equals 1/2 times 2 to the x, and y equals 1/2 times 2 to the x plus 3. Sorry about that. All right, so I'm going to use my calculator. So -3, -2, -1, 0, 1, 2. Those are the values I'm going to use. Actually, sorry. I'm going to do the opposite. Sorry about that. -2, -1, 0, 1, 2, 3. All right, so using a calculator, 2 to the -2 gives me 0.25. I'm not using Desmos because I get a really bad glare underneath my screen, so I'm using the calculator. You can too. You would just change these. Now I did those because I know what 2 to the first is. It's 2. 2 squared is 4. 2 cubed is 8. Now I know I can use my calculator for these, but we could also talk about these. This is just whatever we got for 2 to the x times 1/2. Now multiplying by 1/2, does anyone know what that does to something? If I multiply by 1/2, I'm just cutting it in half. So I already entered 2 to the x and I got 8. If I then multiplied that by 1/2, I would get 4. If you don't believe me, we can enter it. So I'm going to put 1/2 times 2 to the 3rd, and I get 4. And then you could just change, if you are like relying on tables because that's your go-to, you can certainly enter it in your calculator and build this, you guys. There's no reason for you not to be able to do this. Or know that it's these y values cut in half. So if this is 2, this is 1, 1, 0.5, 0.5, 0.25, 0.25, 0.125. Or you can rely on your calculator. This next one, I'm just going to notice I have whatever I got here, but I'm going to add 3. So I'm simply going to just add 3. The x values don't change. So I would take this value here and add 3. So 4 plus 3, 7. 2 plus 3, 5. Right, because I already did this here. So I'm just adding 3 to each of these. 1 plus 3 is 4. 0.5 plus 3, 3.25, 3.125. Okay. So the graphs I'm going to draw below. And I might leave off the 8. We'll see. And this next one, and this last one. All right, so I'm going to plot all 3. This one would be 0.25, 0.5, 1, 2, 4, 8. So it should be a nice growth. This next one, everything's cut in half. So this point that should be at 8 is now at 4. The 4 is now at 2. 2 is at 1, 0.5, 0.25. So notice my graph got cut in half. And this last one, everything is being shifted up 3. So 3, 7, 2, 5, 1, 4, 0, 3.5, 3.25, 3.125. All right, now let's talk about all 3. The first 2, I don't know if you can tell, my floor, the bottom, is right here at y equals 0, but this one isn't. My graph is up here. It looks as though the floor is up here at y equals 3. So this one has an asymptote at y equals 3. These are both at y equals 0. That's your asymptote. I'm just going to put ASY. And notice that plus 3 explains my asymptote at positive 3. Okay, so let's do the domain and range for each, and then we'll move on to D and E. So the domain for the first 2 is the same. All real numbers. Range is y is greater than 0. But this last one is slightly different. The range is greater than where my asymptote is, and my values are above it. Okay, moving on to part D. D says use a graphing calculator and describe the graphs. Well, we have Desmos. And I'm going to skip it because you can enter it on Desmos and describe it. I'm going to go moving on to the last part of this section, which is compound interest formula. So the compound interest formula is the following. Hold on. I have A equals P times 1 plus R divided by N to the N times T. I'm going to break this formula down for you. A is the amount in our bank account or investment account, okay? P is the initial or beginning deposit. R is our interest rate as a decimal. Okay, they always give it to us as a percent. We have to be smart enough to know I can put a percent in my calculator. I have to convert it to a decimal. N is how often it's compounded. And so I'm going to give you a little cheat sheet. If it says daily, well, there are 365 days in the year. So N would equal 365. If it says monthly, there are 12 months in the year. So N would equal 12. If it says quarterly, there are 4 quarters in a dollar. There are 4 quarters in the year. If it says semi-annually, and hopefully you've heard that term, like when stores have a semi-annual sale, that means it happens twice. And then finally, annually or yearly, that would mean N equals 1. The last part of this formula is T. T equals time in years. So I know that's a lot, but you hear it's all in your notes. You can print this, screenshot it, and I'm going to do part E. And there are 2 parts to part E. So they told us we have deposited, in your book it says we've deposit, so P equals 1,000. It told us our interest rate is 6. And it said there have been, that T is 2 years. Okay, there are 2 parts. Part 1 is it's compounded quarterly. So here's what I'm going to write down. The amount in my account equals my deposit times 1 plus my rate, so 6% would be 0.06. Quarterly means that N equals 4. To that, I should have a little exponent button. Number of years times how often I compound it, so 2 times 4. So I'm going to enter this in my calculator that exact way. So 1,000, whoops, clear. 1,000, parentheses, 1 plus 0.06 divided by 4. And then I'm going to hit the exponent button. And instead of putting parentheses 2 times 4, parentheses, I'm going to put 8, right? Because 2 times 4 is 8. And I get, so the amount in my account is $1,126.50. So I earned, if I only deposited 1,000, that means I earned $126.50 in interest. So that's part 1. Part 2, they wanted me to calculate it if it was compounded monthly. So if it's a compounded monthly, I'm now using 12 for N. So the only part in my equation I am changing is where the N goes. So 1 plus 0.06 divided by 12 to the 2 years times 12. So if you're using a nice scientific calculator, I'm going to just change those 2 pieces. So changing 4 to 12. And I'm going to put 24 here because 2 times 12 is 24. And I get something very similar. I get the amount in my account is $1127.16. So it's not a lot more, but it's slightly more because they compounded it more, meaning they calculated my interest more often. And that is it for that section.